Hi everyone, it's Mrs. Summer here to talk about lesson 302, function notation. In this lesson, students will be able to evaluate a function using function notation and determine whether a function is linear or nonlinear. When working with functions, you will see f of x in place of y in an equation, but it means the same thing. So how you say it, f of x equals. Just like we would say y equals, we're saying f of x equals. So in this example, f is the name of the function. And then x is our input in our domain. So what we're putting into the equation. And then equals, whatever comes after the equal sign, so in this case 3x plus 1, is our output or our range. How we would say this would be f of x is equal to 3x plus 1. So determine if the function is linear or nonlinear. So for linear functions, each y value or f of x value is added or subtracted by the same value every time. So in this case, in this example, we can see that every time x goes up by 1, y we are adding 2 each time. So we could write this equation because we do know our y-intercept here, and we also know how much it's increasing by each time. So we could write y is equal to 2x, because what it's increasing by is our slope, plus 3 is our starting point. In function notation, we would write f of x is equal to 2x plus 3. In a nonlinear function, each y value is multiplied or divided by some value every time. So in this case, you can see that each y value is being multiplied, so we're multiplying it by 3 each time. So we're not going to get into how to write that equation at this point, but just know that, so we multiplied each y value by 3 each time. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. You'll also see something that's not linear, nor is it linear function. It's not a function at all, where these values don't increase by a constant number each time. So here in this example, it increased by 2 each time. In this example, it was multiplied by 3 each time, but it was still the same value, which means it's a function, just not linear. If this was 3 and then we had 5, 12, 16, they're not increasing by the same value, so it's not a function. So in this example, I want you to try it. It says this is a linear function. Determine the rule or the equation for this linear function. Then write your answer in function notation. So your answer should be f of x is equal to something. Also, determine the values that go in for a, b, c, and d over here. So in this example, how I'm going to go about it is, how did I get from 5 to 9? I added 4. From 9 to 13, I added 4. So now I know I need to add 4 here. So 13 plus 4 is 17. To go now, we know that from C to 5, we added 4. So what plus 4 equals 5? So 1. So C here is 1. Now, to get from B to C, we added 4 as well. So what plus 4 equals 1? Well, negative 3. So B is equal to negative 3. So if B is equal to negative 3, to get A plus what plus 4 equals negative 3? Well, A has got to equal negative 7. Now, how do we write our equation in function notation? Well, we have f of x is equal to something. If we look over here, we are given its y-intercept. It's 5. So we know that what whatever we do, whatever our slope is, we have to add 5 to it because that's our starting point. Our starting point was at 5. Well, we also determined that we added 4 each time. So 4 would be our slope. Whatever you add each time is your slope. Whatever the value is when x is equal to 0 is your y-intercept. Our equation would be f of x is equal to 4x plus 5. So now we're getting into evaluating a function. So here's one way a question can be worded. Evaluating a function for a given value of x. So this says evaluate the following function for h of 5. So it doesn't matter what letter the function is named. It could be g, it could be h, it could be f, it could be q, it could be any of the letters. So when h of 5, so how we solve that is that it's telling us here that x is equal to 5. So we need to substitute 5 in for x. So we write h of x is equal to 5 minus 3 times 5. H of x is equal to 5 minus 15. So h of x is equal to negative 10. So when you're seeing the equation where it says evaluate the following function for h of 5, it's telling us that here, instead of x, we're going to put a 5 in for any time we see x on this side of the equal sign. So here's another example. Evaluate the following function for f of negative 4 when f of x is equal to 10x plus 4. So I'm going to put negative 4 in for where I see x as my output. So I have f of x is equal to 10 times negative 4 plus 4. F of x is equal to negative 40 plus 4. So f of x is equal to negative 36. So it's very similar to how we were solving questions before, but we've just got it in function notation instead. So here's a you try. Evaluate the following function for g of 2. So g of x is equal to negative 4x minus 5. So how I solve that is I'm going to plug in 2 for x in my output. So I have g of x is equal to negative 4 times 2 minus 5. G of x is equal to negative 8 minus 5. So g of x is equal to negative 13. Here's a different type of problem. It says, evaluate a function when f of x equals some value. So here's a question. Evaluate the following function for when g of x is equal to negative 15. How we solve that is that now it's telling us that this part is equal to negative 15. So negative 15 is equal to negative 30 times x. Divide both sides by negative 30. I get x is equal to 1 over 2. So now it's telling us to set our equation equal and solve for x. So here we're solving for x. So now another question would be, evaluate the following function for f of x is equal to 4. So I'm going to set my equation. 4 is equal to 6x minus 8. Add 8. I get 12 is equal to 6x. Divide by 6. X is equal to 2. Here's a you try. Evaluate the following function for g of x is equal to negative 2 when g of x is equal to 12 minus 7x. So how I go about solving that is I set negative 2 is equal to 12 minus 7, because remember we are solving for x in this case. So I'm going to subtract 12 from both sides. I get negative 14 is equal to negative 7x. Divided by 7, divided by negative 7. I get x is equal to 2.